These were the two questions. Okay. I told you not to do part 2 here. That has F equals MA to be applied there in that. That comes in the next chapter. Forces and motion. We are in the chapter, we are in the topic, forces in equilibrium. Forces that are balanced. Objects that are in equilibrium under a number of forces. There are a couple of forces acting on you, but you are at equilibrium. The forces have cancelled off each other completely. The resultant is zero. This is the case we are considering, and you are at rest. But you know that you can be also moving at a constant speed in a straight line. But in this topic, we are looking at objects that are still, that are at rest, okay, like that or like this. So in this question number 13, you only had to find the values of F and R. Only that part I asked you to do. That is F. So this object Q, it's a small bead Q. It's under, it's acted upon 3 forces. I think this R is the resultant. It's not another force acting on it. This R is the resultant of these 3. Okay. So you had to find F and R. How was that? Yes, Harpreet. Yes, I'll do it. Okay. So let me draw it here first. So this is cross-topic review exercise. I will not write that. This is question number 13 that I gave you for homework. Question number 13. Now, this diagram they have given could mislead you because they have shown R also on the same diagram. So I will draw it like this. You have your bead, that is your object, your point object. There is 20 acting this way horizontally. Okay, I will draw the vertical and horizontal lines, like dotted lines, like a reference. And then you have 10 newtons this way. Angle 30 here. You have to be very clear of what's going on here. And then you have a force like that way. We don't know what that is. It's F. It's acting at 70. A small bead Q can move freely along a smooth horizontal straight via AB length. Okay, we don't need all that. That is needed for part 2. So I hope you realize that to do part 1, you only have to know about the forces acting on this. 3 horizontal forces of magnitude F, 10, and 20 act on the bead. The magnitude of the resultant of the 3 forces is R. So a better way to represent this is not to add the R line to the same diagram, but to say that this is equivalent to, this is same as having the bead with the single force acting on it. Let me show the horizontal and vertical lines again like that. These 3 forces can be replaced with this single R force. That's the meaning. R is the resultant and making a 15-degree angle here. This is the same as that. This is what it is. Okay. We have to find F and R. F and R. So what could be the approach? Here you have the 3 forces. You know the resultant, you know the angle of the resultant force. We have to find the resultant force and we have to find this unknown force acting here. So let's try to find the resultant of these 3. We know that how to find the resultant of a couple of forces. What are the steps? I'll do the simplification this way. What do we do when we want to find the resultant force? We keep any horizontal and vertical forces, we keep as they are, And any slant forces, we split into components so that in the end, we have all our forces vertically and horizontally. Because when we have forces like that, we can add and subtract, and using Pythagoras, you know how to simplify them. So the first step is, let me draw the bead again. I'm keeping the 20 as it is. I am going to split F into the two components. Let me use different colors. Do I have? I had a. Seriously. Can you pass me a black pen? Now that's another disadvantage. Did I drop my black pen? Where did it go? Ah, it's here. Found it. Okay. So I'm splitting F into the two components. So there will be one acting this way and one acting that way. Right? This would be F. This would be what? F cos 70. That would be F sine 70. Right? And then I would split the 10 also into the two components. I'll use red for that. So there will be one acting that way and one acting this way. Okay. So I hope this is clear to you. This F force is what these two are, right? And this 10 force is what these two are now, right? And the original 20 that was acting horizontally is still there. We are happy about that one. We don't need to do anything with that. So what are these two components? This would be 10. This is 10 sine 30. This is 10 cos 30. Now, how many of you did this step? No answer. So I will assume that you have done that step. And then let me keep simplifying. Now, I know that the resultant is not zero. These forces are not balanced. Usually in questions under this topic, because this topic is about forces in equilibrium, your objects, the questions that come under this topic would be in equilibrium. The forces will be in equilibrium. So in a typical question, the object would be in equilibrium. If you knew it was in equilibrium, what you would do now is consider horizontal equilibrium and consider vertical equilibrium. And you would, so vertical equilibrium means this way, upward forces would balance the downward forces and rightward forces would balance the leftward forces. So you would equate total upward equal to total downward, total leftward equal to total rightward. That's what you would do. But now it's not balanced. So we are trying to find the resultant. The resultant that we would find here would we have to equal to that. Okay. So after this, what do I do? Now, can you talk and tell me now, I have R here. I can split that R into two components. Like now, this is this side.
R sine 15 and R cos 15.
That's right, right? This R, I mean that resultant, I can split into two of its components. That is one this way and one this way. This would be R cos 15. This would be R sine 15. Now, these two would also have to be the same. Right? These two were equivalent. This could be written like that. This could be written like this. And these two are equivalent. Now, what this means is that these two, I mean, if you just think of the horizontal forces, they are the resultant of the horizontal forces have to be equal to that. And the resultant of the vertical forces have to be equal to this. Isn't that right? So that's one way in which you can think about this. At this point, I can do this. I can say, if this scenario is equivalent to that scenario, what I can see is that there is a single horizontal forces acting on this. That means these two must result in that. These not two, three. 1, 2, 3. So this must be greater than this by that much. Do you understand that? Okay. So here, if I simplify this again, into that direction, I know that the result is in that direction. That means the sum of these two is greater than that. Okay. So I can simplify the horizontal forces. And the result comes in this direction. It is 20 plus, these two get added up, 20 plus F cos 70 minus, this must be subtracted. Can we know what that is? 10 cos 30 is, cos 30 is root 3 over 2, root 3 over 2, 5 root 3. Okay. Oops, sorry. And then this way, if you think of the vertical forces, I know these two have to simplify into one downward force, which means 10 sine 30 must be bigger than that by that much. So I can say downward, it's this minus this, because I know the result have to be downwards. So I can say this is 10 sine 30 minus 10 sine 30 minus F sine 70. F sine 70. I'm sorry. This I can. This is just 5. 5 minus F sine 70. Okay. Now these two are equivalent. Now what can you do? This must be equal to. This must be equal to this. Isn't it? And then this must be equal to this. So you can write two equations. What are the two equations? Here's one. R cos 15 is equal to R cos 15 is equal to this. 20 plus F cos 70 minus 5 root 3. One equation. And then R sine 15 is equal to, equal to this. 5 minus F sine 70. Number 2. I have two unknowns and two equations. I can solve these to find F and R. The easiest thing to do is divide 1 by 2 or 2 by 1 better. This by this, R will get cancelled and you will get tan 15 here. And you would get a single equation of only F. So if I do 2 divided by 1, this divided by this. So this side you will get tan 15 is equal to 5 minus F sine 70 divided by 20 minus whatever that is, 20 plus F cos 70. You need to solve this. You need to solve this to find F. Did you get an answer for F? Can I know what you got for F? Didn't anyone get an answer here? 1.9. Let's see whether that is right. Yeah, that's right. 1.9 newtons is right. But you got it. R is 12 point. Yes. R is 12.4. Now the thing is this: if you found this really, really hard, that is normal, because it is the first, this question is the first kind of this type, because what they had given here was, now if you see a similar question again, you would know what to do. Here, what they had done was, they gave you 3, 4. Usually, if they had done this, it would be easy. If they had given you all 3 forces with all details and asked you to find the resultant, that would be easy enough. Here, they made it trickier and challenging for you by not giving one force here, but giving an information about R. That's why it was hard here. So you wouldn't know what do I do first? But what you have to understand is, if you think about it, this is same as this. So if I simplify this, it should simplify to that diagram. These 3 forces must simplify to this single force. So that's what I did. I simplified first to the horizontal and vertical components. And then now I know this and this must be the same. So follow that thinking that I went through. And then surely we will come across more questions similar to this now. Then you would know what to do immediately. Okay. So I'm glad that you spend a lot of time and somehow got it. I'm sure that is very rewarding, Hatri. I actually, that is what I like. I like you to go through that process of struggling and spending a lot of time. That doesn't mean that you found it hard. That means that you did it. You have to find it hard because you haven't done a question like that before. But you did it means you solved it somehow. That's what needs to happen. Okay. And as I say this all the time, this so we are covering all different types of questions, because you have to find a seat for an exam, and then at the exam you have to do it fast. That's why I mean, yeah, that's something different to what actual learning is. This is learning, spending a lot of time and getting it yourself and actually solving a problem and being excited about it. Sitting an exam is a different story. It's a whole different game. Anyway, so that's that. And then number 14, this one, how was that? You had to find the tension, S1 and S2. How was that? Did you get the answers? And let me tell you another thing. In mechanics, the theory is very little amount of theory. But you can get very different types of questions to apply that theory. So more than with pure mathematics, in mechanics, you have to do a lot of questions to get that exposure to different, how to apply it if I have it this way, how to apply it there, how to apply it here. You have to get all that experience for the exam. So we would be spending more time discussing questions than discussing theory. Theory is very little. It doesn't take a lot of time to to discuss the theory. But questions we have to discuss nicely. Okay. Now others didn't talk. Others didn't let me know how you found number 13. How was it difficult for you? Did you get
Very hard.
Nathan? Very hard. Okay. Yes.
Yeah, I found the equations, but still I got stuck. There.
Now you
I
have.
came halfway, but the equation went wrong somewhere.
Yeah, it's important that you find where you went wrong. Was it a real, like a normal mistake, or were you actually stuck in the thinking? Were you not able to move on?
Actually stuck. I was really stuck.
You have to now fix that in the sense. Now you saw how I did it. You have to match it up. So I should have thought about it like this. You have to that's the so you have to, now I don't know how, in what process you went through when you were doing this. You have to compare your process with how I did it and match it up and think, so I didn't think about this here, or I haven't gone in a wrong path here. I shouldn't have done that. Why shouldn't I have done that? Because this is what I should have. I mean, you have to like reason and fix that in your head. Okay. So now can you tell me about number 14? Shall we discuss it?
Yes, please.
So in mechanics, it's very important to do and discuss questions. That's where most of the learning will happen, not in the theory. Theory is simple. I thought that I'll find the final answer later, but I have forgotten to do so. But I came to the final expressions for all questions. Okay, Tharindu. So let's look at number 14. Now the reason why in mechanics, you will see I would be doing a lot of the questions I will do them for you. That is for you to learn. So I will be modeling the thing. I will tell you, this is how you have to think. Now, how shall we think here? What can we do here? Why can't we do this? What would happen if we do this? I will show all that. We will discuss all that. That's where you have to learn. So then you have to learn, so okay. So I shouldn't, it's different from problem to problem. I'm just telling you that lot of the learning will happen within a question, when we do a question. So I'm straight away just going to draw this diagram. Let me draw a free body force diagram. So this is a particle P, weight acting down, 21. There are two strings attached to it. So there will be two tensions, one pulling that way and one pulling this way. There are two different strings, then there are two different tensions. They have already marked them as S1 and S2. Now, this is vertically downwards, but these two are acting at angles, and we are not given the angles. Instead, they have given lengths. And I don't know whether you noticed, using those lengths, you can find these angles. Let me draw that. Yes. Yeah. So you have, I'm drawing that on the side here. You have something like that. There are you have two right angle triangles here. This is A, this is B, this is your particle P. This length is 0.25. This length is 0.52. This is how they can make it hard for you. Not making hard. There's more work that you have to do. You have to find the angles. And then this is 0.2. Right? Now you would need one of these angles in order to split these, either this one or that one. The angle made by the force with the horizontal line, or the angle made by the force with the vertical line. One of the two you should know in order to split into components. So let me call this θ1 and this θ2, because I can easily find that would be these two angles. This is θ2, this is θ1. Let's quickly find, I can find theta 1 using these two lengths. This is hypotenuse and adjacent. Theta 1 is cos inverse 0.2 over 0.52. Theta 2 is in this triangle again. I know the hypotenuse and the adjacent. That's cos. Cos inverse 0.2 divided by 0.25. There you have your angles figured. Okay. Do you hear that noise loudly or?
Softly.
Okay. Let me know if it is disturbing to you. I will tell them to stop. Okay. Right. Now, what do we know? I am sure this is in equilibrium. They say the particle P hangs in equilibrium. That means you know that the resultant is 0. If it is in equilibrium, the only thing that you have to do is consider vertical equilibrium and consider horizontal equilibrium. That is what you have to do. So if you consider vertical equilibrium, let me write vertical equilibrium, or you can put an arrow, like I usually say like that, to indicate vertical, or you can write the word vertical. Vertical equilibrium, if you consider, that means total upward forces must balance total downward forces. So what are the upward forces coming? Component of S2, component of S1. So sum of those two, that is S1 cos theta 1 plus S2 cos theta 2 must equal 21. Did you understand? This is upward forces equaling to downward forces. Simple as that. Right? So this is I mean I didn't have, so cos theta 1 is this. How much is 0.2? That's my calculator. My calculator. Let me get my calculator. Where is my bag? Good question. Let me find it quickly. Found it. Okay. So 0.2 divided by 0.52. Oops. What? 0.2 divided by 0.52. Oh, it's not a good number, isn't it? So if I just say S1 0.2 cos theta 2 is okay. So I have an equation of two unknowns. I need another one. I can get the other one if I consider horizontal equilibrium. That is equating rightward forces to leftward forces. Equating rightward forces to leftward forces. So nothing will come from this. There will be a component coming from that. That would equate the component of S2. So S1 sine theta 1 is equal to S2 sine theta 2. Okay. And for sine, how do you get the sine? How do you get sine theta 1 and sine theta 2? One way of doing that is you find your thetas and put the theta here. Or you can use Pythagoras and find this opposite, here. You can use Pythagoras and find these opposite angles and use the length ratios. Either way. So I will not do the algebra. The rest is algebra. And okay, that's another thing I should tell you. In mechanics, half of your problem would be you're setting up the equations and all that is theory from mechanics. But after setting now, once you have done this, your mechanics application is over. What comes next? Pure mathematics knowledge, algebra, solving equations, right? So that you have to now carefully do. Can I, do you want me to continue, or do you think you can manage from here? So the rest is like,
Please continue.
okay. Why not like, that means you haven't done this, no? Have you done this?
I attempted it and it went downhill.
Why did it now have, in your attempt, have you come this far?
No.
What
I made the first equation, but it's nothing like the one which you have made.
It's not.
It's not even close. So that's why I got
Okay.
confused.
So what have you gotten? Where is your mistake? Have you found have you done this?
Yes, I have found my mistake. Now in the first one, miss, you have only put cos there, no, miss. For me, I put cos and sine and some other gibberish which I will not mention because it's not even relevant to here.
Okay, so I hope you realize your mistake.
Yes, it's a very big mistake.
So next time you should not make such mistakes. There has to be an improvement every class. Okay, Nathan? Like
Okay, miss.
if you feel, yeah. Now, so same kind of mistake, if you keep doing, no point, right? Okay, so Hattu says can manage. What do others think? Now the girls, you have to speak to. We can do this if you want, but spending time for the algebra I feel like is a waste of time. I mean, mechanics is only that. But
it's okay, miss. I'll figure it out. I'll figure it out.
Girls haven't spoken yet too. I mean, there's nothing to figure out, Nathan. I help you to figure everything out. The rest is simplifying algebra, solving these two equations. Let's do it. Let's do it. Okay, let's do it because this is the first question like this. So I would now think, I have one equation of S1, S2 here. I have another equation of S1, S2 here. I have sine theta 1 and sine theta 2. Let me see. Let me find theta 1. If that gives me a good, like if I find theta 1 and theta 2 from here, I would not get an exact answer. So to avoid that, let me find these lengths and write the sine theta in terms of lengths. I'm sure, and even that, if there I get not like non-round answers, then problem. Let's see. So square of 0.52 minus square of 0.2, and then square root of that answer. I get a good answer. 0.42 exact. This side is 0.4, 0.48. This side. I did Pythagoras. Okay. Now, if I find that, because I have to do sine, I need that 0.25 square minus 0.2 squared and square root of the answer 0.15. Good. 0.15. Okay. So here actually I should have just said cos theta 1 without doing that. Cos theta 1 is that, and cos theta 2 is that, because I only need cos theta 1 and cos theta 2. I don't need to find theta and theta 1 and theta 2. Then also let me write, so this work happens on the side. Similarly, let me write what sine theta 1 is. Sine theta 1 is 0.42, 0.48 divided by 0.52. Sine theta 2 is 0.15 divided by 0.25. So those two I will put here. Now I'm coming down. Okay, S1 sine theta 1 is 0.48 over 0.52 equals S2 times 0.15 over 0.25. Let me call that as my number 2. Okay. So now have a good look at these two equations. What would be a good way to solve them? You can think of substitution, elimination, anything that you want. Like, be free in your thinking. Would it be easy to make S1 or S2 the subject here and put it in the other one? I think that would be good. Let me make S1 the subject here. S1 is 0.52, sorry, is S2 times S1 is S2 times, I'm like doing like that. Okay, 0.52 times 0.15 over 0.48 times 0.25. Let's see whether that gives a good number. I hope you are doing this with me. Take your calculators and we are doing this together. That is just 0.65 S2. It's exact. I'm not doing any approximations. 0.65 is this whole thing. This whole thing.
Yeah, 0.65.
Is 0.65. Okay, exactly. So S1 is 0.65 at S2. Let me substitute that in sub, if I call it 3, sub 3 in 1. So that is, for this S1, I will put that. Don't make noises. 0.65 S2, that's times 0.2 divided by 0.52 plus S2 0.2 over 0.25. I'm sure these numbers also simplify into nice numbers, even though I keep writing them. So let's simplify the numbers now. What is this whole thing? 0.65 times 0.2 divided by 0.52. That's 0.25. This is 0.25 S2 plus 0.2 divided by 0.25. That is 0.8 S2 equals 21. How easy is that? 0.8 plus 0.25, 1.05. 1.05
is equal to 20.
S2. And then S2 is equal to 21 divided by 20. Beautiful, round, nice answer. Put that in here and find S1. Therefore, S1 is 20 times 13 newtons. Okay, Hatvi is asking me, so the answer we get for S1, S2 are the forces in newtons acting on the weight. Yes, that's what we took to be S1. How? Now, look at this, my force diagram. This is my force diagram. 21 newtons, the weight. This tension I took to be S1. This tension I took to be S2. What I'm finding are the two forces tensions. They are in newtons. Okay. Any questions from this? I will give you another question from a past paper. Any questions until I find this?
No, miss.
No?
Everything is all right.
Girls?
Miss,
Yes. Okay.
what if say that there was a force acting on a point and another force acts on like say there's a thread and that thread is pulled from the other end, so there will be like two forces that are indirectly acting on the point. Do you get what I'm saying?
Can you ask that again?
Say that there is a point, like a point mass, and
Point object, right?
okay, an object, and that is attached to a string,
Somebody's pulling
and
it.
there's a tension in that one.
That's correct.
Yeah, and at the other end of string,
At the other end,
like
is at the other end that you're pulling? Wait. So you have no.
yeah, like
No. Wait.
okay.
Wait, Tharinder. Let me. Can't see that. So let me draw it. That is it. So Tharinder is saying, you have a point object. Is it too bright? Okay.
Bright, too bright.
Good. Now, okay, na?
Now it's okay.
Okay. So you have a point object.
Yeah.
There is a string attached, and you are pulling from here.
No, another string is attached to that string, and you pull from that string.
So this string attached to another string, two strings.
Yeah.
Okay, but it doesn't matter. So you're pulling it. It's like one string then. Why did you attach two strings?
No,
and you're pulling
just
it
say
from
that
both
point is fixed.
Which point is
Just
this?
say that point is fixed.
Yeah.
The one in the middle.
Yeah, they have to be fixed only.
Yeah,
Now these
and the other force is
they don't
moving.
stretch.
It doesn't stretch. Okay, so then Miss, if we were to pull the string from this end where the arrow is, then will it have any effect on the first point?
Of course. I mean, now there was no difference in, you said this is connected to another string. It's same as just pulling with one string. Why did you have to connect it? Now you just think about it. In real life, and one thing, we are under the assumption that our strings don't stretch. If they stretch, the force changes. We don't go into complicated that those theories we don't learn. This theory applies. If you use a string to pull something, if I pull something with by use of a string and by pulling it with 10 newtons, that will act along the string as tension of 10 newtons, and it will be felt by the other object. So it doesn't matter whether you have made this string by attaching two strings or three strings. It's like one string. It's a continuous line of strings. If you are pulling with 10 newtons, okay, this is you holding the string and pulling 10 newtons, and then this tension acting along would be 10.
What if we pull it at an angle? What if we pull it at an angle?
Does it change the scenario? If this is 10, that is 10.
No, that's not what I'm saying, Miss.
Then?
Like the point is fixed, and then from that point we pull the string at a different angle.
Which is this fixed?
That is fixed, and then there's another point in the middle.
That is fixed means, say it's a point on the ground, it's fixed. Is that what you're saying? It's fixed to the ground.
Yeah, okay, that's fixed. And then in the middle,
there is a string here.
Yeah, another point is fixed at the end of that string.
Another point is fixed means, give me a scenario. How can you have that? Like you have another object here.
Say something like
Are you saying, and then you have another string going at an angle?
Yeah.
How can you have that? This will fall down. Is this a string? Now
Yeah, that's a string.
be practical. Then you have something on the ground fixed to the ground, and then you attach a string to that. You hold it like,
Yeah.
and then to that end you put another string in. Can you keep these at two angles? Then this has to be supported to there. Who's keeping it there at two angles? It will fall down.
Oh, yeah.
You can't have such a, so you can have that scenario if you have, say you have a pole like that, and then this goes and there is another object here resting on the pole, and then you have another string. Like, it has to make sense to that. How can you have that scenario? You can't have an object on the ground like that with a string going at one angle and then from there another string going at another angle. That is
No. I'm not talking about the floating thing. No, no. It's like, just say that he's on a wall.
okay, it's on a wall. So this page is a wall. This paper is a wall.
Yeah, the paper is a wall. And then at that space where it turns, there is another object that keeps the string from.
Okay, so this is a pin. Then you have attached something, and this is another pin put into the wall, and then you have another
Okay.
at an angle. Is that what you're saying?
Like, say that we take the same string and then it is first fixed at the starting point, and we coil it around the second pin,
okay,
and then
yeah, and then it goes here,
yeah.
right? And then you're pulling it here.
Yes, miss.
Okay. So say you are pulling it by 10 newtons. So you are here. You are pulling it by 10 newtons like that along the wall. Then the tension, so if you think of the forces acting on this, okay, there will be a 10 newtons force. This is the tension. This same 10 newtons that you are applying on the string acts along the string as tension. It's been pulled by 10 now. So the string pulls this object by 10. You are pulling the string by 10. The string is pulling this by 10. It's transmitted kind of. And then about this, if that is stretched and not slack, that it's very difficult to say. Now you said you coil this around this. That's we are not sure what if that coiling is tight, and I don't know if the same 10 gets transmitted through the coil, and you said it's the same string. If for example, for an instance, if you think this was a different string and then that's another string, then if these there, I don't know, it depends whether this is tight. If you have pulled it, now you pull it and fix the second pin onto the wall, then there will be a tension on this. There will be a tension on this as well that way. If our focus of the focusing object is this, we are thinking of the forces acting on this object, then there will be a tension here, which we don't know the size of. And that would be 10 if you are pulling by 10. But if it was the same string, it's very difficult to say. When you coil it, you won't be given a case. If then they will say assume that the same force will be like transmitted. Then this would also be 10. If we are not sure of that, you would have to. There would be some tension. You have to mark it as T, an unknown T.
Okay, that was my question.
Did that clear what you had, the doubt that you had? What was,
Yes,
what
miss,
was
I
your
was-
doubt? Like, what was your question? Can you generalize it and
would
ask?
the tension in both parts of the string be equal?
Okay. So here's how it happens. We get to that point when we talk about connected particles, because you are talking about two things connected with a string. Say if you have one string going over a pulley here and two particles hanging, then since it's the same string, right, and the two particles are pulling on the string, it's taut, it's stretched, it's tight, it's not slack, it's hanging, then it's the same tension. One string, same tension. This would be pulling up by with one tension, this would be pulling up by the same tension, the two particles.
Okay, miss.
Okay, the tension on this particle and the tension on this particle would be the same because it's the same. There is no like coiling. There's not no big things happening like that. It's going over a smooth pulley. We have to put a lot of assumptions to make these two tensions the same. The pulley has to be smooth, like no other interventions, disturbances. Then same tension. Okay. Here's your next question. This is, oops, how do I go back to, when I go, sorry, wait. Here's your next question. This is, um, this is 2020 June paper, this year's paper, your forces in equilibrium question. The question that came under this topic. Shall we try this? Simple diagram, just 2 lines for the question. You have to find P and theta, 6 marks. Not a lot to read, like the question you had in the book. 1 diagram, 2 lines, 2 things to find. Shall we try this? This is May 2020. Copy the question. I mean, to copy, you just have to copy the diagram and we have to find P and theta. And while you are drawing that, the Taridu's question, now I want you to ask questions like that. It's good. I mean, you have to ask, if we have it like that, how do the forces act? Because these questions have to come to your mind. You have to think of real scenarios. But even a real scenario, we will consider it under certain assumptions. Otherwise, we can't solve these problems. To solve them with the actual conditions of the problem, then you need more theory to apply. But we are just using very simple simple theory here. You have an object, it's acted upon by a number of forces. Very simple, no complications. Like when you have things like that, but it's good to ask questions like that. And you start the question. I'll let you start it, and then I'll come behind you. Okay. Yes, do. No. What do you need to do? Are you done? Did you start? Can I go to the writing pad?
Wait, miss.
Oh. Here, coplanar means they're all acting on one plane. I mean, if they're acting in different planes, because all our vertical and horizontal equilibrium you can only apply if all your forces are acting on one plane. If they were like in a different plane, then there would be, you have to consider more directions. Then the forces have to be in equilibrium in more than vertical and horizontal. Can I go to the writing pad?
Yeah, miss. 5 more minutes.
You are, why I have copied the diagram.
You
Okay.
mean for just copying? Because I'm doing the working and all now.
Yeah. I wanted you to start the work. Can I also go to the document and show you the, I have copied it into the, I mean, you don't need this screen or not? Do you need this?
Yeah, no,
Ah.
you don't need the screen.
Okay. So it's given that the object is in equilibrium. You just have to do vertical equilibrium and horizontal equilibrium. Let me know what your answers are for P and theta. Anyone done? Not yet?
Okay, miss, done.
Done. Can you type what your P and theta are? Each one of you should give me your answers, your individual answers. What you
In
got for
private,
theta?
private or public?
Okay, send me privately.
Okay, miss.
Each one, can you send me your answers for P and theta privately?
Correct.
Okay, let me see. Okay. It's correct. Malik, your answer is right.
Yes.
So you just did the 2022 May paper question and you got 6 marks now. So you will see that the setting up of the two equations by considering vertical and horizontal equilibrium, that would be rather okay. It's the solving, I think the solving is not very easy. I think you get like p square and stuff like that. Do you get like that? Others, how far have you gone in the question now? Bimandi, Hatfi, Joanne, Mihir, Nathan, Rachel, Taridu. Where are you stuck? Okay, Bimandi. Okay, Nathan. Forming the equations you are stuck in forming the equations. That is what should not happen. You should know how to form them. I mean, you can get stuck in the solving. Algebra could be like a little tricky. Well, how the forming of the equations hard? Tell me what you need to do. Tell me. So you can. That's correct, Hafi. Yeah, yeah. So that's correct, Hathvi. Hathvi is correct. Nathan, did you consider horizontal equilibrium and vertical equilibrium? That's correct, Tarindu. Okay. What is your horizontal equilibrium equation? Where did you get stuck in forming the equation? Come, Putta, come. You didn't speak to these ayahs, no? Huh? You didn't speak to these. Put them on. You look what nice in the. Say hello, ayah.
Hello.
Hello. You can't see them, their faces, but they are looking at you. You have anything? You smell good. What did you put? Nothing. Okay. Careful, be careful.
Miss, I got stuck over here. See?
Where? It's too small. Can you turn it other way? I can't see.
Okay, my horizontal one is this, miss.
No, it's too small. Wait. How do I wait, I need to stop sharing and go to this and make you. So you have, can you read it? Can you just read your horizontal equilibrium equation?
Okay, miss. My horizontal one, miss, is 20 sine theta equals.
Wait. Let me go back to the 20 sine. Okay, how do you get 20 sine theta horizontal? Right, you are doing this way. Horizontal means this way.
No, sorry. Horizontal is 20 cos theta
20 cos theta
equals 3p cos 30
good.
plus p cos 30.
That's correct. Okay.
Then my vertical one,
Hmm.
that is 20 sine theta
Huh?
equals 4p.
Wait. Wait. Before you equal, aren't there more in that direction? You have to add all of them.
No, miss. I took them all. I took 20 sine theta to one side. I made that like that way. But if we want that way, miss.
Yeah.
Okay, shall I give the other one then, miss? Hold on. That would mean 4p plus 3p sine theta
Huh?
equals
Huh?
p sine 30 plus 20 sine theta.
So correct. Why did you say you got stuck in forming the equations? You're not
Now,
stuck.
miss, now, miss, I don't know what to do next.
Now you have to. You have two unknowns and two equations. You have to solve them. So let me write those two equations. Horizontal, vertical equilibrium. I will just put an arrow to say vertical equilibrium. When you consider vertical equilibrium, you get 4p plus 3p sine 30 is equal to p sine 30 plus 20 sine theta. You know what sine 30 is. Put them there and simplify. 4p plus sine 30 is root 3 over 2. 3 root 3 p over 2 equals root 3 p over 2 plus 20 sine 30 sine theta. Sorry, sine theta. All these are p terms. You can simplify. You can put them together. Let me bring all the p terms to one side and take the p out. You get 4 plus 3 root 3 over 2 plus root 3 over 2 equals 20 sine theta. Let me label that as number 1. I collected all the p terms together.
Miss, isn't that a minus? That three
minus. Yes, Nathan, this is minus. I take this to I took this term to this side. It should be minus. So that's my first equation. My horizontal equilibrium, I get 3p cos 30. Sine 30 is not root 3 over 2. Sine 30 is half. Half. No root 3. No root 3. Right. So 4 plus root 3 over 2. Who's crying? Who's crying? I mean, I could have, I can like simplify it nicely. So what is 4 plus 3? 4 plus, I don't need the calculator for that, isn't it? But how much is that? Four plus 3 halves. 3 halves means 1.5. 4 plus 1.5 minus 5 is 5p equals to 20 sine theta. P is equal to 4 sine theta. There I have my first equation. Then horizontal equilibrium, 3p cos 30 plus p cos 30 equals 20 cos theta. Cos 30 is root 3 over 2. No Bimandi. No. Let's see, okay? So cos 30 is root 3 over 2, 3 root 3 over 2p plus root 3 over 2p equals 20 cos theta. This is if I take the p out. 3 halves root. Do you know how to simplify this? This is 4 root 3 over 2. 4 root 3 over 2. Do you wait? Okay. This is 3 root 3 over 2 and 1 root 3 over 2 is 4 root 3 over 2 p is equal to 20 cos theta. If I multiply both sides by 2, I don't have to do all that. I'm just trying to like make it, no, this I can, sorry, this I can simplify. This is 2 root 3, that I can simplify as 10. I get p is equal to 10 over root 3 cos theta. I kind of made it into a similar looking equation. Now if I divide them, I can find theta. P will get cancelled. 2 divided by 1. Sorry, 1 divided by 2. I'm going to do 1 divided by 2. 1 is equal to 4 divided by, so 4 over 4 root 3 over 10, tan theta. Theta is tan inverse 10 over 4 root 3. Let me see that. To 1 decimal place, 55.3 degrees. So, I mean, now it's simple to put it back and find P. Now, the point here is, now even Nathan could set up the two equations. I mean, you can't say, I don't know how to go from there. What do you mean by that? So these sine theta, see what I did? So the sine thetas, I put the numbers for sine theta. And then that's an equation. What do you do with an? So before I know this, it's a pair of equations that I have to simplify in the end. But the two equations you have to get to a nice form. That's what I did all this time. So I had, all p terms. So because they were the same term, I took them to one side and took the p out. See, there was a reason for every step that I did. They were not random steps. If I do random steps, you wouldn't know why I do them. But there is a reason to each step that I do. So there is a, it's methodical. It's systematic. It's not just random. And then, see, I got that first. This long equation was only this. Let me highlight them to so you have to be able. This became this, and you should be able to do it. And then for the second condition, this equation became this. I mean, you might not have the same thing, exactly the same thing, but somewhat more or less a similar thing you must also have done. Now I did some, I wanted to get the same form, P equals like the first equation. Is this clear? Do you have any questions, Nathan?
All clear.
Girls? Rachel, how did you find this question? Were you able to do up to a certain point, certain step? And Bimandi, could you now spot where you have made your mistake? Okay, Rachel. Bimandi, did you see where you have made a mistake? Okay. Right. So what we will do is I will send you like 2 more questions to do at home and next time. So that's it for this topic. I mean, for each topic, as I said, we can do very quickly mechanics topics, but you have to practice a lot of questions. Okay. Next time we start the next topic. So 2 topics we are done. Equations of motion, that is linear motion in a straight line, and then forces in equilibrium. Next is forces and motion. There we will learn Newton's second law, F equals ma. So that's very easy to do. Okay. But to practice this type of questions, I'll send you 2 more in the WhatsApp group. Okay.
Excuse me, miss.
Yes, Mihail.
Miss, the answer is 65, right?
Answer is 55.3 for theta.
Okay. Thank you, miss.
And for P, 3.29. P answer is, when you substitute this, you get P equals 3.29 newtons. Yes, Tarindu. Right, yes, Tarindu. Thank you for that. Now, Tarindu is suggesting, I want you to say, tell me things like that, okay? Because I want this to work for you. I don't want